Good afternoon. I'm Jay Scott, editor of ASSE Journal. Thank you for joining us for today's webinar, part of the Journal Supplier webinar series, providing information to journal readers and others about products and technology of interest to industry professionals. ASSE does not review supplier webinar presentations. IntelliHut welcomes you to today's webinar. Is ASSE-1017 and Legionella your worst enemy? Go tankless. Today's presenter is Sri Devasigamani, IntelliHut co-founder and CEO. Sri had the idea for what would become the first on-demand tankless commercial water heater. Prior to founding IntelliHut, Sri spent 10 years at Caterpillar as a mechanical engineer with a focus on marine engines and control systems. He holds a bachelor's degree from Manipal Institute of Technology, India, and a master's degree in mechanical engineering from Clemson University. Sri envisions a future of extraordinary efficiency where not a watt of energy or drop of water is wasted. And now we turn the presentation over to Sri. Thank you.
Hi there. Good afternoon. This is Sri Devasigamani. Thank you for the introduction. I just want to say one correction. The concept of tankless has been around for a very long time. However, what we did, and we do very well, is take that concept and make it work in the commercial space. And some of you may know, but this whole idea started by accident because a water heater broke and flooded my house. And I assume many of you are engineers like myself, and since we didn't have anything better to do, we decided to see what we can do to make it better. And so few years later, here we are, supplying tankless water heaters to the commercial industry. But I think you are here to really hear about what ASSE-1017 and Legionella and perhaps what are the other things that are out there. And before we get started, I think there's a poll we're going to take to figure out why this webinar is happening and why you're attending. But perhaps it is to determine maybe slime is not something from Ghostbusters. Maybe there are other reasons for slime. Perhaps our objective is not to fall asleep. But either way, I am glad you are here to spend a few minutes with us. So before we started the webinar, a countdown clock was pointed out. I'm assuming if you make it to 30 minutes, you actually get credit for being on this webinar. So you got another 26 minutes to go. And I have to tell you, I got about 60 slides. I assure you it can put you to sleep. So today we're going to talk about a few things, really find out what Legionella is about. And all the material I am going to present has all been collected, studied from the National Institute of Health, CDC, and various references. We ourselves are simply quoting what has been extensively studied by the great bodies. Certainly, many of us are familiar with ASSE and the intent of that standard, and then we're going to take a look at what it does and perhaps what it doesn't do as good as we want it to, and see if technologies like tankless can help mitigate that. So the very first question, many of you may know this, so this might just be a refresher. Legionella was first identified back in '76, when the American Legion Convention was held in Philadelphia, and that led to its name. It's actually a fairly naturally occurring bacterium that's found in most water systems. It's actually there both in hot and cold water, and there seems to be an increase. In 2017, CDC reported almost 7,500 cases. And if you look at just the last 20 years, there's been a significant rise in Legionella. And everybody's asking, what's happening? Well, why is this? Why the increase? There seem to be two predominant reasons. One, as every one of you on this line, we are all getting old, but the bigger impact seems to be from these low-flow faucets and shower heads. There is a conservation movement to save water, and part of doing that, one way to give you the same feel as the 2.5 GPM shower head we used to have was to add air to water. And obviously, the more air you add when you turn water into an aerosol, you can inhale some of that, and it is believed that aerated faucets or aerated shower heads can contribute to increase in Legionella. So as engineers, right, we play a critical role, and as somebody said it, in fact, let me quote as engineers, we are in a position to change the world, not just study it. So I'm glad all of you are here. You're going to find a way to really change the world and not just observe it. Where does Legionella thrive? And I'm going to summarize. Really, there are three conditions. The first one is Legionella seems to grow predominantly between 77 and 115. So if you're higher than that, Legionella growth stops. It's still present in water but does not multiply. If you're lower than 77, again, you have the same effect. And then the presence of biofilm, which has been correlated to some extent with stagnation of water. And again, if you read some articles, there are various articles which will tell you stagnation of water causes biofilm. You'll find some articles which tell you water velocities up to certain effect has no effect. But our review of literature in general indicates that stagnation of water promotes biofilm, and presence of biofilm certainly contributes to anchoring and having Legionella grow. So those are the three primary reasons. And this is just showing you the different literature that's out there. If you simply eyeball the ideal growth range, you will see that some studies are saying 90 to 108, some others point to 95 to 115. And then if you generally look at under what conditions that Legionella does not grow, it seems to be about 118 to 120. So if you can keep your water system at or above that, in general, that seems to be a safe zone. Now, you may ask, where does all this Legionella come from? Well, a CDC, National Institute of Health study found almost 50% of the source was linked back to the water heater, specifically the tank-type water heaters. So let's take a quick view of history on how water is heated. If you look in the U.S. today, predominantly water is heated in three ways. All three employ storage. So the first one on your left is a tank water heater, and you might find electric elements inside this, or you might find there is a fire underneath that. So the tank heaters come in different sizes, anywhere from 100 gallons all the way up to 500 gallons. The next common method is a boiler with an indirect tank. Again, you might store anywhere from 100 to even thousands of gallons of water, and you would heat that indirectly using a boiler. And then the last method we often encounter is you have a boiler with a storage tank, and again, the tank might be 500 to 1,000 gallons. All three are kind of good methods to heat water, but they're also excellent homes for Legionella. And the reason is no matter what temperature you store water in these tanks, there are always zones within the tank due to temperature stratification that the water ends up being below 118. Now, if you look at how, as an industry, how water heating is approached, typically there are multiples installed, and the reason for multiples is really to mitigate sudden failures. Restaurants might use 2 or 3. If you are a hotel owner, you might have 2 or 3 boilers with a couple storage tanks. So in one sense, we have simply provided more abundant homes for Legionella. So they're quite happy. Now let's take a deep dive into the 2 different common methods of water heating. So on the left-hand side, you see a tank-type water heater, and there is a flame underneath to heat the tank. The water comes out of the tank. Typically people might keep it at 160, 65. Goes to a mixing valve. It's tempered down to 130. Goes to some shower heads. There is a recirculation pump which then brings the water back to the tank. You could expect 10, 15 degrees drop. So it comes back at say 120, goes back into the tank, and then it's reheated. What happens is every time there is a demand, one of these showers turn on, cold water flows into the tank. And so the bottom portion of the tank really stays in a nice warm, let's call it 70 to 110, 120 degrees. Perfect for Legionella growth. The picture on the right-hand side is very similar. That's using a boiler storage tank. Similar concept. The only difference is in a boiler, the heating mechanism is outside the tank. So you would siphon off quantities of water, heat it, and then put it back in the tank. Again, the goal here is you try to keep the tank as hot as you can keep it to mitigate Legionella. But again, you see stratification of the tank, temperatures between anywhere from 77, 80 degrees all the way to 120. The topmost portion of the tank is 165, but the bottommost portion provides conditions where Legionella can occur. Now, let's look at what happens when you turn on some shower heads. So I'm showing you on the left-hand side a tank-type water heater, specifically a 120-gallon water heater that you can buy today. And let's say it's connected to maybe a full-service restaurant where they have a couple of faucets open, or could be a hotel where typically per heater we might see 10, 12 GPM as peak load. Now, because the tank is so wide, even though you have 10 gallons per minute being demanded as a load, the water inside these tanks literally crawls at a snail's pace. I can think of this as work we sometimes do when I ask my son to get things. He sometimes would move at a very slow pace. But water inside the tank really crawls at this velocity. Now, when you look at larger storage tanks, this might be, say, a hotel or a condominium or a multifamily. You could have a 1,000-gallon storage tank, and you might be drawing as much as 20 gallons per minute. So that 1,000-gallon storage tank, the velocity is virtually standstill at 0.2 feet per hour. So literally slows. Now, what I'm trying to share with you here is, given the velocity that looks almost standstill, results in water being stagnant and not being in the turbulent range, and again, it's being correlated with formation of biofilm. So you have the right temperature, you have stagnation of water, both of them can create biofilm. Again, that really leads to more Legionella. So as engineers, we think about robust design. Certainly, we at Intel are fans of robust design. And what robust design really is, let's design to mitigate the root cause. So in this case, the root causes are temperatures between 77 and 115 and stagnation of water. If you look at the current methodology, and there are good reasons why we are here. Historically, we've been using tanks. Historically, we stored water in these large containers. So we have to come up with a way that's fairly effective as much as possible in combating Legionella. So the thinking was, why don't we simply sanitize the water? Let me take temperature to 160, and let's see what happens. So there are a couple things that it does do well, a couple things it doesn't do well. So the things it does well, it does kill Legionella, or there is belief it kills Legionella, because when Legionella comes in contact with 160 water, it potentially dies. The only challenge with that is, while that may appear to be true, the data today is showing that Legionella is on a rise. So fundamentally, we have to take a step back and ask, if keeping water at 165 was a foolproof method, then why are we seeing increase in Legionella, and why is it being attributed to tank water heaters? The second thing that the current methodology may not address, it really does not address the root cause. The root causes, as I indicated before, is temperature stratification and formation of biofilm. It would be great to have a solution that takes bullseye aim at the root cause and eliminates it, but this one doesn't. And then, of course, there are other things that kind of get in the way. You do have to employ potentially costly pieces of equipment, mixing valves, and potentially introduce unreliability in your system. From time and again, we run into owners and engineers who often describe the unreliability they have introduced because of additional valves and equipment. Also, fundamentally, if you think about keeping water at 165 or 170 and storing literally thousands of gallons, it is fundamentally at odds with initiatives like Title 24. On one hand, we want to reduce our energy consumption. Obviously, a bigger goal is not to have anybody die. They kind of seem to be at odds. So the question is, isn't there a better way, and can we fundamentally eliminate root causes of Legionella? So one option we'd like to present to you is thinking about heating water in an entirely different way. So when we think about tankless, and essentially tankless literally means elimination of tank, the concept is fairly straightforward. Why don't I heat water on demand and then kind of deliver that water when it's ready to be consumed? And the picture you see there shows you a typical heat exchanger. Cold water enters at the bottom, out comes hot water at the top. And in this particular design, you can see that when water velocity is at 10 gallons per minute, the velocity inside these tubes, and these tubes are almost 3/4 inches in diameter, the velocity is almost 8.5 feet per second. Now, studies have shown that if your water velocity is between 8 and 12 feet per second, you can, in fact, scrub away any biofilm. So fundamentally, having water in these higher flow rates and in the turbulent region can mitigate one of the root causes of Legionella. The second one is, because you're heating water on demand, the temperature inside this is never in the ideal range for Legionella growth, and you can always keep the temperature above 118. Let me show you how this technology is deployed. So here is a look at a tankless heater, which is that big black box. Within that box, you might have multiple heat engines, and all these heat engines are wired together. So hot water comes out at the top, goes to your shower head. There is no mixing valve between the water heater and the shower heads. You go through a recirculation pump, and you come back at 120. So in this system, the water entering the water heater is higher than 118 at 120, and the water leaving the unit is at 130. So we have eliminated another root cause which promotes growth, which is to never have water below 118. Now, thinking about how such a system might work, here is an example when just one shower head is on. You might only have one engine on to supply, to meet this load, and the other engines are in standby. And as the flow increases, you might have more engines come on to meet the load. And perhaps at your peak load, you might have almost all the engines firing to keep up the load. So what we are able to do with this technology is really not store any water and provide you with ample water irrespective of what your building demands. So to kind of summarize, one thinking behind tankless is there is no stagnation of water. Obviously, there is no stratification of temperature because there is no large tank. And because you're able to keep velocities higher than 8-9 feet per second, there is no biofilm formation. And again, there is no room for Legionella growth. Now, I want to share with you some of the other standards that are being worked that are on the horizon. There is a new standard that is being worked called ASSE-1017. And the thinking behind this standard is tankless water heaters now can serve as a temperature control device. In fact, tankless, simply by their nature of design, they have to strictly maintain temperature control between ±4 as your loads change. It has been found that the human skin can detect temperature variations of plus minus few degrees. So the general standard most tankless water heaters would target is keeping the temperature variation to a very small ±4. So since tankless can meet that, the thinking behind the standard is tankless water heaters can control temperature without the need for any additional equipment. So the standard is being worked on. There is tremendous support for the standard, and I want to really say a shout out to all the engineers out there who have supported this standard and who are furthering this. We believe it's the right thing to do. And the general expected rollout for this is in 2021. So a couple of things to take away. We believe that with tankless you can eliminate Legionella. You can also eliminate unreliability in your system without having to introduce mixing valves. You can also save money by not having to deploy expensive valves. And then if you don't keep your water hot 24/7, that helps you significantly drop your energy consumption. And obviously, if you're not storing thousands and thousands of gallons of water, you free up a lot of real estate. So in all around, there is significant both CapEx and OpEx benefit in addition to fundamentally addressing root causes. And I think with that, we are at the last slide. And I think we will now open it up for any questions. As a reminder, I think you have to be on for at least 5 more minutes to get the credit, right? So I am told that IntelliHot will issue a signed company certificate of your personal attendance after viewing the presentation. Where applicable, this certificate may be applied to your state's continuing education requirements. So we will now take questions. Okay, one of the questions is it not rare that such large tanks in your presentation are used today? We are talking about 1,000-gallon storage. Well, actually, it's not rare at all. If you walk into your local McDonald's, you would see two tank type heaters at 120 gallons each. If you walked into your typical hotel, a 100-room hotel, a 200-room hotel, typically they would employ, the 2 or 3,000 gallon tanks in their mechanical rooms. The standards are being rewritten. Numerous hotels are considering going tankless because the thing that they do provide is a clean bed and a hot shower. So there is significant concern in the hospitality and the food industry about Legionella, and they certainly want to address the root cause and eliminate storage. Yeah, there's a question about water velocity. Yes, there is a typo on our slide. The water velocity should be 0.5 feet per minute and not per hour. So there's a question, and this is a very valid question. In fact, a question that I myself, as an engineer, first and foremost, have pondered. Question is, the general thinking is let's keep the tanks at 165, 170, and any bacteria that comes in contact with it should instantly be killed, right? The thing is, while that that seems to be true, the data and facts are not supporting that. What a CDC study, and it's there part of our citation, has found is almost 50% of the cases have been attributed back to the storage tanks. And the thinking is either the bacteria is not getting killed or there is production of bacteria certainly there is production of bacteria outside the tank water heater that also contributes to Legionella. But fundamentally, the thinking now is simply keeping water at 165, given the stratification of tanks, is not enough. The other thing that happens, which many of you may or may not relate, when you have a bank of tanks, you might have, and it's very common to see 2 or 3 storage tanks deployed in an installation. When one of them fails, essentially that ends up becoming a large storage tank keeping lukewarm water. So in that case, simply because of building recirculation, you have turned an entire tank into one that holds water at 115, 120, because it's lost its heating function. And certainly that we have seen cases where that promotes Legionella growth. So there's a question on with tankless and multiple heat exchangers, do you need to add alternating control? So no one heat exchanger remains idle. I could share with you how we do it at IntelliHot. We view all of our heat exchangers as individual robots. So each engine communicates with every other engine, and then they automatically rotate. So no engine is idle. In fact, there are several layers of safety built in. So if one engine were to go down, it automatically isolates itself and lets the other one come online. So all engines are automatically rotated and exercised, and the water through them is constantly kept moving. Again, more questions on tankless. I'm going to take this one. Do you still recommend the use of tankless water heaters for emergency plumbing fixtures, such as emergency showers, which will require significant electrical consumption? Well, I can speak for IntelliHot. The units we make run on gas, and certainly, yes, you can use them for emergency showers. We have several installations we have done, and in fact, it's a good choice because the units occupy less space, and obviously you're not keeping a lot of water hot all the time. So it would be a good choice for emergency showers. You know, there's a question here which is an interesting, thought-provoking question. If Legionella continues to be an increasing concern, will it come to a point where future engineers are specifying almost exclusively tankless water heaters? So here's what I have to share about that. You know, I'm a big believer in robust design. So if I were designing a braking system, I would design a system to brake. I would not design a system to not chatter. And essentially, that philosophy, of thinking is called Taguchi design, robust design. So if I were designing a hot water system, I would love to design a system that fundamentally addresses root causes rather than come back and apply Band-Aids. So whatever system we as a group of engineers decide, and certainly we at Intel Hot believe tankless is the right choice. Certainly there may be other methods, but we should design a system that fundamentally eliminates root causes and eliminates all of the root causes, not just one or two. There's a question on how expensive are tankless water heaters compared to gas-fired tanks. What we have seen here at Intel Hot is we are very, very competitive. What I'd like to say is generally based on what we deploy to the market. If we have some online sizing calculators that you're welcome to try out. We typically come out with a 50% reduction in CapEx. And that's because you don't have to double up the amount of equipment you have to use because we have redundancy built into our system. If your building needs a hot water capacity of 100, conventional wisdom will tell you to double that. So you might put in a redundancy of 2x. We would tell you to put in 1.25 because we have redundancy built in. So that right away has the effect of dropping your CapEx by almost half. And we have seen that time and again. In fact, that's one of the reasons we are very, very, very successful. Okay. I think with that, we are concluding our webinar. Please visit our website. Feel free to send us a note at our website. And again, thank you for the opportunity. Have a good rest of your day.